This is a short lesson that takes rational expressions one step further and looks at complex rational expressions. These are rational expressions that have numerators or denominators that have a rational expression in them. So you can see example A there. I've got 1 plus 1 over x all over 1 minus 1 over x. That's a rational expression. And we're going to look at simplifying them. To simplify them, multiply the numerator and the denominator by the lowest common denominator of all the rational expressions. So you look at all the rational expressions that are in this, and you see that we've got an x here and an x here. Those are the denominators, so our lowest common denominator will be x. So we're going to multiply numerator and denominator by x. And you'll see how that turns us into a not so complex rational expression. Okay, so I'm multiplying by x over x, so it's still 1. So multiply carefully through the brackets. So we're using the distributive property, making sure that x is multiplied by both terms. So in my numerator, I end up with x times 1, which is x, and x times 1 over x, which is 1. So I end up with an x plus 1. In my denominator, I have an x times 1, which gives me an x, and an x times negative 1 over x, which will give me a negative 1, and I'm finished. So this very complex looking rational expression is actually equivalent to this one, which is now not such a complex version of it. Let's look at another example. If I look at example B, I've got more complex stuff happening because I've got 1 over x minus 3 over 2 all over 1 over x plus 3/4. So again, let's find our lowest common denominator. I've got an x and a 2 and a 4, so all of those will go into 4x. So there's my lowest common denominator. So I'm going to multiply numerator and denominator by that. So 1 over x minus 3/2 all over 1 over x plus 3/4. And I'm multiplying by 4x over 4x. Okay, so I'm doing 4x times 1 over x, and I'll just show that off to the side here. 4x times 1 over x. So remember, that's 4x over 1. So that gives me 4x over x. X divided by x is 1, so I end up with a 4. So 4x times 1 over x gives me 4. So that'll give me a 4 in the denominator as well. Then if I do 4x times negative 3/2, I now have 4x times negative 3, negative 12x all over 2, which gives me negative 6x. And if I do 4x times 3/4, 4x times 3/4, I end up with 12x over, sorry, that should be 4, over 4, which gives me 3x. Okay, so it very quickly, this method very quickly gets rid of those sort of fractions within fractions types of things and makes our rational expression much easier to deal with if we needed to now add, subtract, multiply, or divide it. So one more example. This one's a little more complicated again because I've got an x over x minus 2 and a 3 over x squared minus 4. So let's look at our denominators. The denominator, one of them is an x minus 2, and the other one is x squared minus 4. So let's factor this one. This becomes x plus 2 times x minus 2. So our lowest common denominator, think about when we were working with rational expressions, will be x plus 2, x minus 2, because the x minus 2 goes into that. So x plus 2, x minus 2. So now we're going to multiply our numerator and our denominator by that. So it's probably easier to separate those out, okay? So let's look at just our numerator for starters. So I've got x over x minus 2 plus 1, and I'm multiplying that whole thing by x plus 2, x minus 2. Oops, x minus 2. So let's take a look at, sorry, that does not look very legible, does it? X plus 2 times x minus 2. Okay, so let's see what happens when we do that. I've got this x over x plus 2 times x plus 2 over x times x minus 2. So you can see that if we just ignore the 1 for now and just multiply that first term, you can see that those x minus 2's are going to divide out and simplify. So we end up with x times x plus 2. Okay, and now we'll take the 1 and multiply it by that. So we've got 1 times x plus 2, x minus 2. Let's clean up that numerator now. So I've got x squared plus 2x plus, and x plus 2 times x minus 2 will give me x squared minus 4. So that will be x squared plus x squared, 2x squared plus 2x minus 4. We may need to simplify that out and factor that at some point, but that's our simplified numerator. Okay? Let's take a look at our denominator now. And we're going to multiply it also by x plus 2, x minus 2. So I've got 3 over x squared minus 4 plus 1 all times x plus 2, x minus 2. Okay? Keep in mind that the x plus 2, x minus 2 is the same thing as the x squared minus 4. So when I multiply this first term by this is going to simplify with the denominator, and I'm going to be left with 3. And then I've got plus 1 times the x plus 2, x minus 2, so that'll be plus x plus 2, x minus 2. And keep in mind that's x squared minus 4, so x squared minus 4 plus 3 will give me x squared minus 1. So there's my whole denominator. So let's put them back together. Let's put our numerator and denominator back together again. So our original question now is equal to 2x squared plus 2x minus 4 all over x squared minus 1. Now it looks like that might simplify because we can factor the numerator, we can factor the denominator. So let's first look at the numerator. We can common factor a 2 out. So we've got 2 times x squared plus 1x minus 2. And we've got x plus 1, x minus 1. Now let's look at this by inspection. We need two numbers that multiply to give us -2 and add to give us +1. So that could be a +2 and a -1, correct? So this will give us 2 times x plus 2 times x minus 1 all over x plus 1 times x minus 1. And our x minus 1 divided by x minus 1 simplifies. So we have 2x plus 2 all over x plus 1. And phew, we're so glad we're finished that piece. So that is dealing with complex rational expressions. Just multiply numerator and denominator by the lowest common denominator of all of the rational expressions.